are Liberty Mutual students, and I would say that's also worked out very well with Doug. I have very much enjoyed all of the conversations we've had. It feels like when I'm talking with Doug, I'm talking more to a peer or an equal than a student, because he takes such great pride in learning absolutely everything he can. And so we're always able to have these great conversations where we're bouncing things back and forth with each other. And Doug is just, his thirst for knowledge, I think, is unparalleled by almost anyone I know. Every time I think that there's nothing more that Doug can learn out of this course, he takes something else and he goes even bigger. Just like Eric, he's incorporating some information in his final presentation that he didn't even learn here. He wanted to go and challenge himself. So you'll see some work on natural language processing that Doug hasn't learned here, but went and did himself. The other thing about Doug is that he's always a helper. He has helped so many of our students that are a little bit less advanced than him along the way. He'll show up at office hours and just help others out when he can. And he's even helping us write a little bit of curriculum on something called Power BI, because it's something he feels very passionate about that we should be including. And he wanted to take the lead with my help, and I'm so grateful and thankful that he's interested in doing that. So Doug, will you please kind of tell us a little bit about yourself?
Yeah, well, thank you, Meredith. You read all the sentences I fed you and even added a couple of your own, so thank you.
Ha ha.
So my name is Doug Neathawk, as Meredith has said. I'm a data analyst for Liberty Mutual Insurance. I've worked there about 15 years, and half on the business side and half on the IT side. The title of my presentation today is So You Say You're a Data Scientist. So a little bit more about myself, because it's my favorite subject to talk about. I'm a self-professed data enthusiast, but I came by the technical side of data through an unlikely path. When I started on the IT side, part of what my team was tasked with was capacity management and left shifting and right sizing work from one team to another. And to be able to do that, we needed to measure the work, measure the capacity of the teams, assign skill sets to it. And in order to do that, we dove in and built this tool that we called State of the Operations. This was largely and fully based in Excel spreadsheets. And the success of our team quickly outgrew our ability to turn out these models for the teams. We started off with a team of 30 people, and last year we had models set up for over 600 folks out in the Power BI web space, which is why I'm so passionate about it. It really freed up my time to be able to move the model forward, move our analysis forward. So because our tool outgrew my ability to pump these models out, we really needed a technical resource on the team, and we were not able to get one. So I was put in a position where I needed to become the technical resource, and I did this unwillingly. But what I've learned about myself is I truly love the technical side of this data stuff, and it's really for three reasons. One is the problem solving aspect. I love problem solving, and this is not just about solving the problem, but it's also about solving the code and solving the delivery of the solution to the customer in a manner that it's consumable for them. There's also a friendly competition. So all of us on this call could be assigned the same problem. We could all reach a solution that's acceptable, but some of our solutions will be more elegant than others of us, and I love that competitiveness involved in this stuff. And then continued relevancy. So the picture on the right, that's my motorcycle, and in August, before I joined the program, I took a motorcycle trip to get all my yayas out before I had to focus and bear down on the program. That's a picture of me on the Blue Ridge Parkway. And this is how I envision my future. So someday I want to be able to ride my motorcycle and pull my laptop out of my saddlebag and be able to make a living doing that. And I view data science and the skills I've learned in Woz U as the key to being able to do that. So a project statement, and I'll just let everybody know, if you guys want to interrupt me, if you have questions or if I miss something, please feel free to do so. So as a development data science professional, I'm curious what the state of the union is out there. What does a data scientist look like? And am I a data scientist? So looking at Kaggle's data sets out there, they each year, or I should say for the last 3 years, I think, have put a survey of aspiring data scientists and machine learning experts. And the 2018 survey data was published in December. So I took that, viewing it as a good measuring stick as to what people are doing and whether or not they consider themselves a data scientist. So my project is revolving around a very selfish subject, and that has the path I've taken ultimately led me to my goal. So using, through this project, I'll use the skills I found within the Woz U curriculum. I'm going to use the data set found on Kaggle for the 2018 Machine Learning and Data Science Survey. And I'm going to use a number of open source software libraries. For the presentation, we'll gloss over some exploratory data analysis, and we'll talk about a couple different modeling techniques that I used, unstructured as well as structured, or unsupervised as well as supervised, I should say. And then if in fact I am a data scientist, we'll go out and look for a job using some web scraping and text analytics. So there are 8 million stories in the exposed data set, and this is just one. And this is a reference to an old TV show that used to end each episode by saying there are 8 million stories in the naked city, and this has been one. So as I looked at this data set, there were nearly 24,000 respondents within the data set from 58 countries, and they answered 50 questions. And as I began looking at the data, and a lot of it was text data, or it was non-numerical data where there were ranges and ages and selection-based, I found a number of different stories that, a number of different angles that you could go at. And what's cool about Kaggle is the data set's out there and people will share their notebooks, so you can get an idea of how other people are looking at their data sets. So there were 256 different workbooks out there, or different takes on this data set. If I added mine, it would make it 257, and I haven't looked in a little time. It probably would be even more. So you could take an angle at looking at the ethics in data science and what people think about bias in our data sets as well as our algorithms. You could also look at this data set from the angle of repeatability and the issues that we have from a scientific perspective, where if I took Devin's research, could I arrive at the same results, and why I might be able to as well as why I might not be able to. You could also take a look at it from a demographic. So who is doing data science, where do they reside, what do they look like, and what tools do they look like? What tools are they using, excuse me. But as I said, I'm taking a more selfish approach to compare myself to these folks to determine whether or not I have reached the status of data scientist. So this slide here on the left-hand side, these are just summary findings. And before learning these techniques, this might be a really typical approach that I might take to a question like this. So I take a look at the population, 81% male, and I'm comparing myself to all of these. 46% of the entire population had a master's degree, 8% had a business background, 58% of them use Python, 30% of them spend a half of their time at work to 3/4 of their time coding. And then I compare it to the scientists or data scientists, those folks that said they are data scientists, and it looks pretty much the same. So before learning these techniques, I might, my logic might go something like this. Compare myself to the population. I look very much like that. Compare it to the scientists. The scientists look like the population. I look like the population. So therefore, I must be a data scientist. What's cool about these techniques is that we can put a little more rigor around our analysis to more definitively define whether or not we've reached at the right conclusion. So on the right-hand side, we have, do you consider yourself a data scientist? This was one of the 50 questions. This is where I've decided to narrow my focus. There were, out of the 24,000 folks that took the survey, 18,500 of them answered this question. So I narrowed my data set down to these 18,500 people. About 9,600 of them said either probably yes or definitely yes, they are data scientists. So that's about 40%, and that will be my target. Those are the folks that I want to compare myself to see if I actually look like them. And I included the 58 countries because I thought it was neat. So across all the countries that submitted a survey response, at least one data scientist from every country. So now that I've narrowed my data set down to what I want to focus on, there was some data pre-processing that needed to occur. And I want to thank both Eric and Devin for going through some of the steps of this, which will enable me to skip over some of this. So the first thing I did was shape my data. I want to take the targets out from the features, and I think you guys have heard a lot about features or variables. If you're familiar with an Excel spreadsheet, you could think of a feature or a variable much like a column in your Excel spreadsheet, where each column that represented a particular question would now become a feature. So I take my features and I separate it from my targets, which would be that question I just shared with you, are you in fact a data scientist? 1 would represent yes, I am, and 0 represents no, I'm not quite there yet. And once I do that, most of these machine learning algorithms work the best with numerical data. So although I had 253 features in my data set, only 6 of them were numerical. So 98% of the data I was dealing with was categorical, which presented me with some unique issues to deal with when getting my data into a usable format. So one of the techniques you'll use with your categorical data is to encode it. There's a couple different ways to do that, but the easiest way for me to explain would be if I have a column and the column title is color, and within that column we have values of red, green, and blue. The encoding process will take those columns, those different values of red, green, and blue, and it will create individual columns for each one, where then it will set a binary indicator of 1 being yes, it's red, and 0 being no, it's not red. So when I get through encoding, it bloated my data set from 253 features up to 449. The other thing you'll do when you pre-process your data is to scale it. So scaling is to put all of your numerical data onto the same order of magnitude. If you're thinking about trying to predict the price, the selling price of a home, a couple of the features you might look at is the number of bedrooms, which could be 1 to 4 for a normal home, but the square footage would be in the thousands. These algorithms like our numerical data to be on the same plane or the same order of magnitude. So by scaling, you put your data more closely together so that the algorithm can determine the difference between these points. And then last part we would do is to reduce or simplify the data set. So the more data that you have or the more features that you have, as your features and dimensions grow, the amount of data we need to generalize about these data points grows exponentially. So although more data is good, when we're talking about adding features to it, we really want to focus on narrowing down our data sets to feed the algorithms only the things that make the most sense to it. And we'll use a technique called PCA, or principal component analysis, to combat our curse of dimensionality. So this graph that we're looking at here actually is our PCA analysis. So I had mentioned we had 449 features, and what we've done now is take all of those and we feed it to this unsupervised algorithm where it will boil down those 449 features to the number of components that you tell it. And the whole point of this is to retain the greatest percentage of variance between our data, because that's what truly is predicted within these algorithms. It's predicting the greatest difference between our data points. So we had 18,500 folks that answered this the survey. The Woz U blue folks are data scientists, and the black dots are not data scientists. So if we were to chart our 18,500 based on these two components, this is what it looks like. And as you can see, there's no clear delineation between one color and the other. We're all grouped in there together, which really highlighted for me, if you think back to when I was speaking to what I might have done, when I compare myself to somebody that looks like a data scientist without using these mathematical methods, I could walk away and feel good that I arrived at the right answer. But mathematically speaking, we're going to be able to get to a much more sound conclusion. So when we kept two components, the reason why I kept two components was for two reasons. It explained 55% of my variance. If I was to do a full analysis, I probably would keep more of them. But I kept two because I wanted to be able to visualize for everybody what it would look like if we charted all 18,500 people. And to be able to do that in a multi-dimensional space is much more difficult to do, as well as to understand. So now that we have our data reduced, the dimensionality of our data reduced, one of the things I wanted to do was use a k-means cluster. And I thank Devin for showing what a good k-means cluster looks like, because this is not a good k-means cluster. If we look back to this, where everybody is intermingled, data scientists without data scientists, when I applied a k-means cluster to this data, it essentially took a linear pick. The centroids in the middle are the center points of my two clusters, and then it will try to fit our data points to one of those clusters. And in the end, we ended up with a 27% homogeneity, which means we want to fit in our clusters everybody that belongs in that cluster. And because there is so much dispersion in the data, we weren't able to do it using this technique. So I spent a lot of time. I know that there must be a way to be able to do that. And there is a lot of conversation around using categorical data for these techniques, because in the end, it's trying to measure the distance between data points mathematically. And if you remember, I said 97% of the data set I was using was categorical, which means my numbers ranged from 0 to 1 by and large, which does not give a lot of distance between the data points, which is a lot of words for me to say this is not a good technique to use on this particular data set. I have since gone out and find some other techniques, and I'll probably circle back to try and find a way to better measure the categorical features so that we can get a better k-means clustering. One of the techniques used to interpret our clusters are decision trees. So then we moved on to create a decision tree. I know both Eric and Devin had spoken about making decision trees. This is a random forest, which is an ensemble method. And what random forest does is it takes one single decision tree, except it will make however many of them you tell it to. So in this case, our model is set up to make 500 decision trees, and then it takes the average of those decision trees to arrive in an answer. So as you can tell by the slide, congratulations, when I create the model based on the 18,500 folks that responded to the survey, and then I took the survey myself and fed my own answers to the survey, it arrived at the fact that, congratulations, I am in fact a data scientist. So after we had the parade here at the house and everybody celebrated, I started to think about, if I was to productionalize this model at work, 68% may not be good enough. In fact, I would guess that folks would turn their nose up at 68%. So trying to think of how I could increase the predictability of the model. There are three things that I would do if I was to try to performance tune this model for production. And the first thing I would do is go back and get more data. So I mentioned that this is a 2018 survey. I'd probably go back and get the 2017 survey and the 2016 survey as well to get more respondents into the model so that it would have more things to learn. I would also spend a lot of time reducing features. So we fed this model all 449 of the features, which is definitely not a good technique. a lot of those features, especially at the tail end of the model, because it will rank our features in order of importance. We could truncate many of these features and make our model much more production friendly, as well as much more performant. And then parameter tuning. I know there was some talk earlier today about parameter tuning, and in this case, we're actually visualizing. This would be one of the trees, one of the decision trees that we made, and somebody had mentioned how you could prune these limbs. So we had 449 features here. I'm essentially stopping at the first 3 nodes, and I'm also within these nodes, you can determine the number of values within each node upon which to make the split. So simplifying these models, you want to feed them more data is better, but you want to make sure and feed it the right data. And you also want to make sure that a simple model, in many cases, is much better than a more intricate and complicated model. So this is the path that the arrows here are the path that I took when I took my test. The algorithm actually started here, and this topmost node is called the root node. And what the model will do is it will take the parameter that you feed it that is the most predictive and the easiest best cut. It's going to take its first cut, its best cut first. So in this case, the answer to that question up top is none of these activities are important to my role. There's a question within the survey that says, select all the activities in your role at work that are important. And one of the options is none of these things are important at work. So the model took a look at that, and it determined very easily that if people say none of these activities are important to my role, that's a very easy way to cut the data set in half, essentially. If you're not using this at work, then you're probably not a data scientist. Then the next one was greater than 50% of my time spent coding. So again, yes or no answer. I actually spend about 50% of my time at work doing code. So I move on to the next node where it's what are the frameworks that are you using over the last 3 years? And this is actually scikit-learn, so I got to answer affirmative there too. So within 3 quick questions, it was able to determine that I was a data scientist. So now that we've established that I am a data scientist, I wanted to talk a little bit about how did the model determine you're not a data scientist for folks. We fed it 449 individual features, but a lot of the predictability comes from the most important or the most heavily weighted features that you feed it. So again, simplifying the model. And to get to an affirmative decision that you are a data scientist, the model really weighted heavily on good percentage of your time devoted to coding, a good diversity in the use of the tools, so not just languages, but also open source packages, as well as visualization, cloud-based as well as local-based, and then a high importance of these techniques at work. To the contrary, for the folks that had determined that they were not data scientists, the most important or heavily weighted features were no importance of these techniques at work, a really low percentage of their time devoted to code, and people that are showing interest in data science but weren't actually acting on it. When I shared this at work, I was talking about it with my boss, and he said it was interesting or paradox in that you know, this particular one about finding it important at work, it's difficult for folks trying to get into the industry where you can't get a job without the experience and you can't get the experience without the job. But in our world, my experience has been such that, you know, we have access to data, and it was an opportunity for me to bring these techniques into work without them asking, which has really facilitated and accelerated my personal growth and professional growth. So now that we know how to become a data scientist, and I know that I am one, my interest would be to go out and take a look and see if I can get a job doing data science. So what we're looking at here is the Indeed website. And I am searching for data scientists in New Hampshire. And then using the package Beautiful Soup, I was able to write some Python code that will go out for me now, and I can set it to run however often I want to scrape the website for Indeed and bring back however many jobs for data scientists are listed in New Hampshire. So in this case, when I last ran it to make the slides, there were 15 openings, and I've highlighted one just to show that the information we're bringing back is the title, location, company, salary, and then a synopsis of the job, which is really interesting because that's where the meat is in my estimation. I want to be able to know what are folks looking for, what are they advertising for, what are the skills that I should be focusing on and able to get a job. So we use Beautiful Soup to scrape the data and bring it back. And also let everybody know, if you are going to go out and use these techniques, make sure and check the website and their user agreements to make sure they allow for web scraping. A lot of these job sites did not allow for web scraping, but Indeed does. So I was very happy to see that there was at least one option for me to do this. So now I've got my 15 jobs back, and I have a synopsis of all the individual jobs. And I don't want to read all of the synopsis. By the time I get done reading the second one, or the 15th one, will have forgotten what this senior scientist life cycles job is, or life sciences job is. So we'll create a word cloud, which is really easy for me to take a look at the top 25 skills that these 15 jobs were looking for. Word clouds are kind of neat. They have pros and cons. They're really easy to understand. They're kind of like a pie chart in that it's difficult to determine, is data more important than scientists? But from this perspective, it was really useful for me to take a look at those top 25 terms and compare myself to them. So because I want to compare myself, we did some natural language processing or text analytics, and there are a number of different techniques going on in this one slide where we're taking a look at just the individual terms and getting counts for them. So data obviously was the #1 term. It was referenced 15 times. And then I have the ability now to take a look at the terms that are within the synopsis of each job and see whether or not I have it. So being very liberal to myself, it seems like I'm checking all the boxes. The co-location, the key terms up top are individual tokens. The co-locations, I find that technique really, really powerful in that these are words found next to each other within the text that have a statistical significance for this particular text. So it isn't like we're looking for and the, which could be found in almost every text everywhere all the time, and something we wouldn't want to put much weight on. This co-location are statistically significant based on this text, and it makes sense when you look at it. So analytical data, outstanding individual, strong background, data visualization, data mining, this all sounds like the skills that we are learning within the program here. The other technique that we're using is there's an ability, because now we know the frequency of the terms within our text, we're able to weight our sentences. Some of these text algorithms within NLTK, which is Natural Language Toolkit, have the ability to weight these sentences. So if you think about, instead of reading all of the 15 synopsis, I'm able to tell the algorithm, give me the 5 most important sentences. And what I'm showing you here is just one of those. So this is the #1 important sentence in the synopsis for those 15 jobs. And when I read that, I feel pretty good about my skill sets, and I probably will go out and find myself a data scientist job. When I combine the text analytics here, as well as my random forest or decision tree, both of these two have made me feel really comfortable about the fact that I have in fact reached my goal. I have been on the right path. So in conclusion, I included an article here from LinkedIn that just came out where they say that data scientist is the #1 promising job. So us folks on the Woz U Data Science program are on the right path in 2019 for a very promising future, which is awesome. I couldn't wait to share that with everybody. But I also, because I feel like I'm really far down this path, I wanted to share some advice to everybody. And the first being always be coding. So this process has really highlighted to me the importance of it. When you look at 18,500 folks across the board, there were many, many different visuals I didn't share, but most of them were pointing out to me that you should be using these skills actively as much as you can. Also to get involved. So I didn't share any of it, but there was a lot of data in there about the communities that you participate in and where you get your information from, as well as the ability to get mentorship and giving back. All of that stuff was very important for those folks that answered the question of, are you a data scientist, in the affirmative. So mentoring is interesting. Even when you think that you are not strong enough to be mentoring folks, I highly advise you to think differently. There's always somebody out there you can help, and I encourage you to do so. Join your Woz U community more. Join these conferences. There's tons of meetups for free. There's always something that you could be plugged into to help. And then also give back. A lot of these open source packages and libraries, you think that you need to be a Python or an R coder extraordinaire to be helpful, but documentation these guys need help with. There's always an opportunity and a place for you to fit into the community, and I highly encourage you to do so. And then the last thing is put it in your path. Really highlighted to me when I got through the analysis that the folks that are making this important or are in places where it's important are reaching their goals. It's definitely attainable for all of us. And even if you're sitting at work and thinking they don't care about this stuff, I think it's an opportunity for you to help highlight the strength and the power of this stuff, and for them to help them understand that it's important. And that's all I have for you today.
Doug, thank you so much. That was a fantastic presentation, my friend. And yes, you are in fact a data scientist. So I can't thank you enough for really the closing remarks, because that it really kind of ties in the message that not only our DS students, but our cyber students and our software dev students should really take to heart, in terms of just like you said, the always be coding, but building that network, building their portfolio, adding the depth, the lifelong learning mentality that we mentioned that each of you guys have obviously adopted, is just paramount to not only your growth in this field, but in every field when it comes to technology. And each of you guys have just done such a phenomenal job with your presentations, and with you, just a great job in just affirming what we already knew, which was that you are in fact a data scientist. So Meredith, anything you'd like to add to the presentation?
Absolutely, reaffirming that Doug is a data scientist, and that mindset of always learning is going to take you very far. And I hope you're able to continue staying engaged like you recommend, not only with every other organization that I know you're helping out, but also here at Woz U. I know there was mention of creating a data scientist team to do some of the Kaggle competitions or things like that. So I hope that becomes a reality at some point. That would be wonderful.
Yeah, that's certainly my intent. I kind of feel like I have found a home here. Meredith has been awesome, coaching me not just technically, but in other areas too. And yeah, I really, really have appreciated it. And I think that we should do that. We should probably get these Kaggle competitions are free. As a team, we could probably get a small group together and show the world how good we are.
Excellent.
Very cool. Very, very cool. Do we have any other comments or questions from the group? All right. Well, guys, again, can't thank Eric, Devin, and Doug again for their time today. Everybody that was here for the presentations, thank you so much for supporting these guys. Meredith, just hats off to you for your leadership and your guidance and your mentorship to all of our students in the data science program. And we just want to thank everybody today. for being here, and say congratulations to these three. The sky's the limit. You guys are off to bigger and better things, and we certainly look forward to what each of your futures hold. So with that, we'll close it out for the day and say congratulations to the three of you guys, and we look forward to speaking with each of you and seeing where our paths cross next. So take care, everyone. Have a wonderful afternoon. And those of you guys, as we mentioned early in the presentation, that are out there in that crazy weather, you guys be safe, be careful, and stay indoors.
Thank you.
Thanks, guys. Take care.
Thank you all. Great job. Bye.